Hi guys, this is the video for chapter 3, lesson 2, titled Angles and Parallel Lines. So our last class, we took a look at lines that were intersected by another line, and we call that a transversal. So last class we talked about how there are certain angle relationships that we see when we have a line that's several lines that are intersected by a transversal. So what we're going to look at today is something very similar to that, but we're going to add on a special quality to these lines. The quality that we see is that they're both parallel. So something interesting happens when we see parallel lines being cut through, intersected by a transversal. So if you are familiar already, we looked at interior angles, exterior angles, alternate interior angles, alternate exterior angles. We had a corresponding angles and consecutive interior angles. So one thing that's interesting is that corresponding angles, alternate interior angles, and alternate exterior angles are all congruent when two parallel lines are cut by a transversal. So let's take a look at what that would look like. So corresponding angles, that means, that basically means they're in the same position. So if we look at this picture here, angle 1 and angle 5 are corresponding. They would be exactly the same degrees. And all others that are in the same position, 2 and 6 would be equal, 4 and 8 would be equal, and 3 and 7 would be equal. They would be also congruent, right? So all corresponding angles that are that are angles formed by parallel lines cut by transversal are congruent. Let's take a look at alternate interior angles. So alternate interior angles, that would be something like angle 3 and angle 6. So 3 and 6 would also be congruent. Another set of alternate interior angles would be like 4 and 5. Those would be congruent also. Alternate exterior angles, so if we took a look, let's use a different color here. Maybe 1 and 8. So 1 and 8. See how this right here and this right here, they are the same size. So those are congruent. And then 2 and 7, angles 2 and angle 7 would be congruent. So 2 being right here, 7 being right here. So those would all be pairs of angles that have a relationship of being the same. Now, consecutive interior angles, those are angles that are on the inside, sandwiched inside the two lines, and on the same side of the transversal. The relationship between consecutive interior angles is that they are supplementary. So an example would be angle 4 and angle 6. These would be supplementary. They add up to be 180 degrees. Another example would be 3 and 5. So angles 3 and angles 5 adds up to be 180 degrees. So those are all examples of these types of relationships that we see. So the example down here, we've got two lines cut by transversal P, and they tell you the degree measurements of these angles, or it's actually in the example, it says in the figure, angle 2 is 75 degrees. So now your job, or the job here, is to determine all the other angles. So if we're given one, I think we can find the rest. So looking at angle 1 and angle 2 add up to be a linear pair, which means angle 1 plus angle 2 has to be 180 degrees, right? Now, if I know angle 2 is 75, I could replace angle 2 with 75 degrees and work this out. Angle 1 plus 75 should equal 180 degrees. And then I could subtract 75 from 180, and I would find that angle 1 is 105. So if angle 1 is 105, I think I can assume that angle 3 would also be 105. Do you guys know why? Why would 1 and 3 be the same? It's because they're vertical angles, right? So if you have two lines that intersect, the angles that are across from each other they form, those are vertical, which means they're also congruent. So I can conclude that 1 and 3 would be 105. What do you think angle 4 would be? It would be 75. So now using this, let's come up with the relationships down here. Angle 5 would be 105, and there's several reasons why. We could look at angle 1 and 5 and see that they're corresponding angles and know that corresponding angles are the same size, and so angle 5 would also be 105. Or I could use the characteristic of consecutive interior angles. Consecutive interior angles means that there are two angles sandwiched inside the two lines, and they would be supplementary, meaning 75 plus angle 5 should be 180. So 75 plus 105 equals 180. And so angle 6 here would be 75 degrees. This would be 75 degrees, and this would be 105 degrees. So what we're going to do down here is we are going to be given an angle measurement, and you have to tell which type of angle relationship you used. So basically, you're using one of these 4 corresponding angles, alternate interior angles, alternate exterior angles, or consecutive interior angles. And remember, you can shorthand them by writing this as CA, writing this as AIA, AEA, and CIA. So you can shorthand these terms by writing them by the letter it starts with. So let's take a look here. Angle 3, I'm going to mark it on here. Angle 3 is 102 degrees. So I need to find angle 5. Now, what's the relationship between 3 and 5? The relationship between 3 and 5 is that they are alternate interior angles. The lines that form angles 3 and 5 are M, N, and P. P is the transversal. So 3 and 5 are sandwiched in between M and N, and they're on opposite sides of the transversal, so alternate interior angles. And we know that alternate interior angles are congruent, so that means angle 5 is also 102 degrees. Okay, angle 6. What's the relationship between angle 3 and angle 6? They're consecutive interior angles, so CIA. And that means 102 plus angle 6 should equal 180. So I can work that out by doing 180 minus 102, and that would be 78 degrees. Okay, angle 11. If we're looking at angle 3 and angle 11, what's the relationship between the two? So if we're looking at that now, the lines that form those angles we're looking at specifically, angle 3 and angle 11, would be right here, or these lines, right? P, Q, and M is the transversal. So 3 and 11, now the relationship between the two is that they are corresponding angles. So if they're corresponding, they are also congruent, which means 11 is 102 degrees. Angle 7, let's take a look. Angle 7 and angle 3, 102, and angle 7 here, well, these lines M, N, and P form those two angles. 3 and 7 are both in the bottom right corner, and so that would be corresponding angles as well. And so angle 7 would be 102 degrees. Try 15 and 14. Pause the video and try 15 and 14. Okay, angle 5. Number 5. Angle 15 is a corresponding angle with angle 3, and so they're both in the bottom. I guess they would be the bottom right corner, and so that could be corresponding angles, and it's 102. Now, you didn't have one transversal with these, so you actually really needed to look at two. First, you could say that it was corresponding to angle 7, and then 7 and 15 would be corresponding, and it'd be 102. So 14 and 102, we know that 14 should be 78 degrees, and you could say that angle 2 and 102 are linear pairs, and then 2 and 14 are corresponding angles, or you could say 102 and 12 are consecutive interior angles, and then 12 and 14 are alternate interior angles. So you kind of have to jump through two hoops, I guess, to get to the final explanation of why those are the certain degrees that you've given it. So why don't you guys pause the video and do 7 through 12 and see what you guys get. All right, as I'm working through these, I'm realizing there's something I haven't told you. Right here, P and Q, I want you to think about, are P and Q parallel? No, they're not. V and W are parallel, but P and Q are not. So what I'm looking at this, even though there might be a special characteristic between these two angles, I can't use the same conclusions that I did for the ones on top if the angles aren't parallel. So be very careful with that. Let's take a look at number 12. So we're going to look at angle 9, looking at angle 12. So angle 12 is a linear pair with angle 9, and so we could subtract 180 or 80 from 180, and angle 12 would be 100 degrees. Number 8. Number 8 and angle 8, sorry, number 1 and angle 9, it looks like we've got parallel lines here cut by the transversal. And so we can conclude that 1 and 9 are in the same position, meaning they are corresponding angles. And so angle 1 would be 80 degrees. Now, be careful that you don't look at 1 and 5 and look at them as corresponding angles, because P and Q are not parallel. So I can't conclude 1 and 5 are the same measure. And if you look at the picture, you can even kind of tell this angle is bigger than angle 5. So be careful with that. Angle 4. So angle 4 is here. It looks like, I don't necessarily know for sure what it is, but I had found angle 12 earlier, and angle 12 was 100 degrees. So angle 4 should also be 100 degrees because of corresponding angles. It's corresponding angles with angle 12, right? Number 10, angle 3. So 4 and 3 are linear pairs. So if 4 is 100, 3 would have to be 80 degrees. So you could say it's a linear pair or some other explanation. Linear pair with angle 4. Number 7, looking at 7, it looks like 7 is directly across from angle 5, and this is what we call vertical angles. And so 7 is vertical from 5, and so it's the same measurement, 68 degrees. And I could say vertical angles. Vertical, we could even say vertical to angle 5. That might be a little more clear. Okay, number 16. 16, let's see, we've got my transversal here, and then I've got V and W. Those are parallel, and then my transversal is Q. And so the relationship I'm looking at is between these angles and these angles. So 16 is down here. If 5 is 68, and 8 is a linear pair to that, or we could say 7 is 68, right? Because that's vertical angle, we just found that. Then what would 16 be? So how do we find 16? I think we would have to do 180 minus 68 to get our angle measurement. And that would be 112 degrees. So 112 degrees. And so we first looked at angle 7, and then that was a vertical angle. And then we looked at that 7 and 16 and concluded that those were alternate interior angles. And so that told us what it was: vertical angles. I'm right, VA, and alternate consecutive interior angles were what helps me figure that one out. Okay. So this really just takes practice of looking at them and being able to recognize how to tell what's what. Now on the bottom, we're going to apply this to some algebra, okay? So we're going to solve for an unknown value. Here, let's take a look at what our pictures are showing. Number 1 here is showing that this whole angle is 5x minus 5, and then this angle that's supplementary to it, or a linear pair with it, is 6y minus x. We need to find the variables of each figure. So down here, we've got 4x plus 10. So when you're looking at this, you might have to kind of extend this picture out a little bit to create those line relationships with the transversal. So if I extended this out, what I would notice is that this angle right here and this angle are in the same position, and they're both equations that have the variable of x. So if I have the same variable, I can probably solve for it. So I could say that 5x minus 5, would it be equal to or supplementary to 4x plus 10? Well, they are corresponding angles, right? So corresponding angles means that they are equal. So it equals 4x plus 10. Now I can work this out as an equation. So this becomes x equals 15. So x equals 15. And then now I have this angle down here. I know that 5x minus 5, this angle, plus 6y minus 4 should add up to be 180 degrees, because this is what we call a linear pair. They form this line. So I could sub x into the equation and do 5 times 15 minus 5 plus 6y minus 4 equals 180. So now I can work this out like an algebraic equation. I can first work out my numbers. So 5 times 15, what would that be? 75, I think. Let me double check. 75 minus 5, I'm going to bring everything down. Okay, and then I'm going to work all my like terms out here. So I've got 75 minus 5 minus 4. And that would be 66. And then I've got plus 6y equals 180. So now I'm going to do 180 minus 66. 6y equals 114. Divide by 6. And y equals 19. So my answer is y equals 19. All right. So I found this because I knew these were a linear pair. And I might even explain that that's because of linear pair relationship. Okay, this one would be corresponding angles. All right, number 2, the relationship between all these angles here. It looks like if I were to extend this line out and this line out, well, first of all, this tells me these are parallel. So that's key for me to know that I've got some parallel lines. And this would be my transversal. So these two inside would be what we call consecutive interior angles. And if we look back at our notes from above, consecutive interior angles are supplementary, meaning they add up to be 180 degrees. So I'm going to use that idea to help me find consecutive interior angles. So we've got 90 plus 3y plus 18 equals 180. Okay, so now I work this out. 90 plus 18 is 108 plus 3y equals 180. Subtract 108 from both sides. And I've got 72, 3y equals 72. Divide by 3 on both sides, y equals 24. Okay, so I found y. Now I need to use those angle relationships to, well, I need to use another set of angle relationships to figure out this pair here. I've got these two parallel lines. This would be my transversal. And so what's the relationship between these two? Again, I have consecutive interior angles. So consecutive interior angles means that 15x plus 30 plus 10x equals 180. They add up to be 180. So if this were angle 1, this were angle 2, I would say 1 plus 2, angle 1 plus angle 2 equals 180, right? Now I can work it out. So 15x plus 10x is 25x. If I subtract 30 from both sides, I have 150. So 150 divided by 25, what would that be? Is 6. So x equals 6. And there it is. So I found x and I found y. Down here, take a look. I've got two pairs of parallel lines. So really I can look at these. Let's see. These would be consecutive interior, or I could even look at, and these would be consecutive interior. Yeah, so I can say that 11x plus 4 plus 5x equals 180. Okay, so now I have 16x equals 176. 176 divided by 16. Did I do that right? Looks like a decimal, doesn't it? Oh, it equals, no, it doesn't. I don't know what I was doing on my calculator. Okay, x equals 11. Yeah, I must have just been dividing by 6 or something. Okay, and then these two angles would be consecutive interior as well. So they add up to be 180. 5y plus 5 plus 13y minus 5. I'm literally just transferring this whole expression into this spot, and that equals 180. So 5y plus 13y is 18y. And then 5 plus negative 5 is 0. So that's what I have here. 180 divided by 18 is 10. Y equals 10. All right, last one. So we've got a lot going on here. I've got two parallel lines, so identify your parallel lines, and then now you need to identify your transversal. So if I were looking at this, I've got x and x. Let me see if there's a relationship between the two. If I imagine that these are my two parallel lines, and this is my transversal right here, what's the relationship between 3x and 5x minus 20? Those would be alternate interior angles. So alternate interior angles tell me they are congruent. So that tells me 5x minus 20 equals 33x. So this type, looking at the angle relationships is what tells you how to set up your equation. If you don't know the angle relationships and the characteristics that follow those relationships, you can't actually solve it. So I'm gonna work this out. I've got negative 20 equals negative 2x, and then divide by that, and that equals 10, x equals 10. Now, looking at this line here, we need to solve for y. So be careful. When I look at where my transversal is, that cuts through 4y and 2y there, what I realize is 4y is this whole angle, and 2y is just part of this angle. But the relationship between these two angles, if I was looking at this as consecutive interior angles, would be this whole thing. These two are consecutive interior angles. So I've got to think through, well, this whole angle is found by doing 2y plus 3x, because 3x plus 2y composes this whole angle. So because of that, I'm going to have to do a little extra work to solve what this part is and eliminate this extra x, because I want my equation to only have y's. So I'm going to write this by plugging in what I had found for x earlier, which was 10, and working this out. So now I have 2y plus 30 is this whole angle right here, is 2y plus 30 if I eliminate my x value, okay? So the relationship between these two angles, consecutive interior angles, tells me when I add them up, it equals 180. So 2y plus 30 plus 4y equals 180. So now I can work this out. 6y equals 150. I'm kind of working some of this in my head. And when I divide by 6 on both sides, this equals 25. So y equals 25. So be careful. Think through the visual of what's going on and if it makes sense, if you're looking at the right angles, okay? Last two problems. So it says find the variables, value of the variables in each figure, explain your reasoning. So we've got a little more going on. First of all, we've got z, x, and y. So we have to use what we know about certain relationships to find each thing. Let's look at y first. If I'm looking at this, 2y and 106, what's the relationship between the two? Well, they together form a linear pair. They form a line. So I'm going to say that 106 plus 2y equals 180 degrees. Now 180 minus 106 equals 74. And then so it's 2y equals 74. Divide by 2 on both sides, and y equals 37. So I worked this out, got it. Now I need to solve for x. So if I'm looking at this, I've got parallel lines. This is my transversal. X and 106, what's the relationship between the two? Well, they are alternate interior, no, they're consecutive interior angles. So that means x plus 106 equals 180. And as I had found that earlier, x equals 74. So x equals 74. And then finally, I'm going to look at the relationship between 4z plus 6 and maybe x here, because I've got my parallel lines here. This is my transversal. So always identify what are your parallel lines, what's the transversal before you identify the angle relationship. So 4z plus 6 should be, let's see, would be supplementary also to x, because I know if this is x, then this would be x, and so if this is 74, this would be 74. So 74 and 4z plus 6, add them together, and that should equal 180. Okay, so we can work that out. 6 plus 74 is 80. And then we've got 4z plus 80. Okay, so subtract 80 on both sides, that's 100. This is 4z. 100 divided by 4z is 25. So z equals 25. Yay, we found all of them. All right, last one. Last one here. So we're identifying our parallel lines. These are our parallel lines. right here. And let's see, my transversal. So there's several options, right? This I can look at as my transversal. I could look at this as my transversal, right? But be careful here. When you're identifying like this as your transversal, that means this whole angle is seen as one, okay? And let's take a look at what we have down here first. I've got 2x, 90, and x. This is probably from a previous lesson that you did in chapter 2. But if I look at this, all these angles, this angle plus this angle plus this angle, have to add up to be 180 degrees because all these are linear pairs. So 2x plus 90 plus x equals 180. So that's one way I can solve for x here because they have the same variable down here. So I have 3x plus 90, which when I subtract, that equals 90. 3x equals 90, x equals 30. So x equals 30 here. If I plug that in, this is 30, and this would be 60, right? Now I need to find y and I need to find z. So if I look at my parallel lines and then look at this being my transversal, what's the relationship between x and z? It looks like they're alternate interior angles. So x and z are alternate, no, not, sorry, not alternate interior angles. They're on the same side of the transversal. They are consecutive interior angles. So 30 plus z should equal 180 degrees. And if you work this out, z would be 150. All right, which means if z is 150, what is this? How many degrees is this angle? That angle would be supplementary to 150, making it 30 degrees, right? 180 minus 150 would be 30. So 30 degrees is what 2y is. And we can solve for y by just dividing by 2 on both sides. And y equals 15. Okay, there you go. Good job. That looks like everything for lesson 2. Being able to identify those angle relationships and then just really replacing that angle with the expression is all you really need to do, okay?